Hey guys, what's happening? It's Coach Hammett coming to you from beautiful Georgetown, Texas, here in room 122. Hope you're having a great day. Going into 7-5, we're about halfway done with this section. It is a long, or this chapter, it's a long chapter, I know. And it's been so long since we've graphed anything, I think today would be a great day to jump back into it. So we're going to be graphing some stuff and dealing with exponential functions. So we're going to have variables in the exponents, okay? Just like we've been doing, just like we've been solving for x. This time we're going to be graphing, okay? So we've got y equals 2 to the third, or 2 times 3 to the x. Remember, this x is only acting on this 3. The 2 is before that. Our formula is going to be y equals ab to the x, okay? A, in a lot of cases like this one right here in the middle, is just going to be a 1. You might not even see it, okay? So if you just have one number with a variable or in the exponent, just think of the other number as a 1 right there, okay? B has to be greater than 0, okay? B is greater than 0. B can't be 1. Why would it not be 1? Well, if B was 1, if there was a 1 in these parentheses right here, 1 raised to any power is still going to be 1. So that would just be a flat line, all right? And we'll get to some more stuff with that. So let's jump in. We're going to graph y equals 4 to the x. Now, what we've got here is just a little xy chart, okay? And so they said that x is -1. Well, 4 to the negative first power is 1/4. All right, if x is 0, 4 to the 0 power is 1. 1, when x is 1, y is 4. When x is 2, y is 16. So this isn't going to be linear. It's not a quadratic yet, but we're almost there. This is an exponential, okay? It's going to have big growth right there. So you can see the points that they graphed right here. -1, 1, 0, 1. I'm sorry, -1, 1/4, 0, 1. 1 is 4. 2 is all the way up to 16. That is an exponential graph. That's an exponential growth, okay? You just put the dots on there and you draw a nice curved line through there. Keeps going up, all right? Okay. The graph crosses the y-axis at 1. That's going to be a big deal. Y-intercept is 1, all right? Now, our formula doesn't really have that because it's just y equals 4 to the x. So there's no y equals mx plus b. You just got to remember the y equals ab to the x values, okay? Domain. Domain is all real numbers. This line keeps going to the right. It's just really, really tall when it does, okay? The range are all positives. Now, there's a new word, the asymptote, all right? Asymptote, all right? That is this line right here that this blue line approaches but will never touch. It will never touch y equals 0. It might be right next to it, but it will never cross y equals 0. Okay, and you can look at it right here as to why. 4 to the -1/millionth power would just be 1 over 4 to the millionth power. Okay, so it's never going to pass that 0 right there. We call that the asymptote. The asymptote, sorry, I keep saying it wrong, asymptote. There you go. All right, so let's keep going. We're going to graph y equals 5 to the x. Y equals 5 to the x. Now, I want you to think about this. If we put a -1 right there, it would be 1 over 5. All right, so -1 would be 1 over 5. It looks like the only one that it could be is b right there. All right, so let's look. 5 to the 0 power. Well, that's going to be 1 right there. Anything to the 0 power is 1. 5 to the first power is 5, and so that's our curved line right like that. Okay, all right, so what if we have a fraction right here? Okay, that's going to look a little bit different for us. Okay, because remember, think about this. If we have a negative exponent, what's going to happen to this? It's going to flip. All right, so -1 would actually be 4 over 1. All right, so there you go. -1 would be 4 over 1, which is 4. Anything to the 0 power is 1, and then 1 would be to the 1/4. If we graph that, it looks like this. It's reverse from what we were doing before. Okay, what's the asymptote is still 0, and that's kind of a bad line right there because it does get on the black, but it will be approaching it. It'll never be touching it. All right, domain, all real numbers. Range, all positive numbers because the asymptote is 0 right there. If the asymptote was -1, the range would be everything above -1. Okay, so let's keep it going here. If we graph y equals 1/8 to the x power, all right, answer is going to be A right there. Again, things that you can check for. If it's 0, more than likely it's going to be 1, as long as there's not a number out here in front. Okay, we're not here yet. That's linear. That could be an option, but again, the 0 gives it away right there. Okay, so exponential growth, exponential decay. If it goes up, it's growth. If it goes down, it's decay. All right. Domain are all reals in both of them. Range, all positive, all negative. Okay. Actually, I don't like that for range, all negative numbers. That's not the right thing right there, okay? Because right here, our range would be still all positive numbers, so that's not really cool. All right, there's one y-intercept. There are no x-intercepts in this formula, okay? All right, let's keep going. Here we go. The function v equals 25,000 times 0.82 to the t is depreciation of a new car that started at 25,000. V represents the value. T represents time in years. Okay, graph the function. So just put it in a graphing calculator. Instead of a t, put an x right there. Okay, that's what it's going to look like. And what you can do is you can go to your table and you can see, hey, in 5 years, 1, 2, 3, 4, 5, the car is going to be worth this much. Now, there's a point where even any car is going to value out and be like, well, it's not going to lose money any more than that. It's going to level off. Okay, it's still losing, but it gets very, very flat. You can see how much it loses in the first few years right there. This is a pretty good world example. All right, if you buy a new car, you're going to experience a lot of depreciation at the start, and then it's going to kind of start to trail off. Okay. All right, so value after 5 years, we put a 5 in there, we press enter. That $25,000 car becomes a $9,268 car. So it devalued quite a bit after 5 years. Welcome to real life, guys. Okay, just looking like that, y'all could tell it was D just from the ones that we've done so far. All right, we're going to skip that one. Here we go. Ba-da-ba-da-bum. Oh, exponential behavior, identifying it. Explain why and why not. Look for the pattern. Is there a pattern to this? Okay, the domain values are at tens. Okay, so what can you tell me about these ranges? Well, to go from 10 to 25 is times 2.5, times 2.5, times 2.5. So we've got a pattern to our info here. All right, so since it is a pattern, we can go, it's 2.5 to the x, 2.5 to the x. And we're going to be looking at these patterns a whole lot during class. All right, you've got to know the difference between a linear pattern, an exponential pattern. Later on, there'll be a quadratic pattern as well. So there you go. Look right here. Is there a pattern to the top? Yeah, it goes up by tens each time. Is there a pattern to the bottom? Yeah, there is. It divides by 2. It looks like there is. Yes, there is. Okay, so it cuts in half. We'll talk about patterns and stuff more in class and how we're going to deal with them. Other than that, guys, that's 7.5. Get ready for a lot of graphing and drawing those exponential functions. We'll see you in class tomorrow. Bye.